magic when I put it together is magical. 11. You got two forces. It looks like identical forces in opposite directions. So this looks like a couple to me. Two forces, each of magnitude F, form a couple acting on the edge of a disc of radius R. The disc is made to complete n revolutions. So you got extra information. This is spinning with n revolutions. About an axis through its center, as you can see, normal to the plane of this. We'll write down an expression. So you need expression. Basically, in this case, an equation that shows the distance moved by a point on the circumference of the disc. So you want distance. Distance moved on circumference. So we know the equation of a circumference is 2 pi r, where r in this case is the radius of circle, with center at the center of circle. But they suddenly ask distance. Why? We have additional information and revolutions. Okay, this is only for one term. But here there might be more terms. So therefore our answer is the required distance is equal to n times 2 pi r. Okay, a straightforward question to show you sometimes you just need to extract the right information and then just focus on the equations for each part and then you can answer. 2. The work done by one of these forces. So work done by one force. Again, remember, work done is equal to force times distance moved in the same direction. So in this case, let's just make it simple. We got distance, we got force, therefore it's just force F times distance of n times 2 pi r. Okay, then we move on to B. Using answer to A, which is this, the work done. Show that the work done by a couple producing a torque T when it turns through n revolutions is given by. So now they want the work done by a couple. Okay, so this work done by a couple will be equal to 2 pi n t. Okay, for n revolutions. So we need to show this. So we got work done by one force. Now work done by couple. So in this case, it should be 2 times this one. So let's just assume it. So work done by 2 forces will just be equal to 2 times this whole thing here. 2F and 2 pi. So we need to show this. So what is a torque? We know torque is equal to one force times perpendicular distance between 2 forces. It's always good to rewrite this again so that you have a better understanding. One force is F. Perpendicular distance between 2 forces, again, this part here. Let me extend the line action force. This one is 2R. So F is equal to 2R. Okay, so let's see whether we can extract that and rewrite this. So let me just rewrite this. We need F2R, F2R. Okay, so I'm going to extract 2n and pi. So 2n and pi extract symbol tau, so 2 and pi. So it corresponds to this one, therefore show. Okay, so QED. This to show that it has been proven. Now we move on to C. A car engine produces a torque. So a torque of 470 Newton meters. This is a car engine. And it is at 2,400 revolutions per minute. Sometimes we call this as 2,400 RPM. You hear the term RPM quite often, especially in engineering. Calculate the output power of the engine. So, power output. So, power output, this is not electricity, but three equations. You got work done per unit time is equal to twin of work done is energy per unit time because they have the same units. Time, force, time, velocity. We already have the equation for work done is 2 pi and t. So in this case, your work done is 2 pi and big T, that is your torque, over T. So let me rewrite this as 2 pi torque n over T. N over T will be this guy here, which shows you how many revolutions. Revolutions is n per unit time. Time is in seconds. So you got 2,400 revolutions per minute is equal to 2,400 n over 60 seconds. So the zero cancel. And you get here will be 1 and 40. Okay, I hope that's right. It's not the use calculator. I double check that. So it will be 2 pi. Torque here is 470 times by n over t, number of revolutions per second. In this case, it will be 40. Okay, and then I calculated me, so please just check that number. And hopefully you're going to have a value of 1.2 and 10 to the 5 watts. Okay, this question is trying to remind yourself about key points. One force, torque requires two forces. After that, reminds you how to find your torque. It's not a substitution, but it allows you to understand if you got any other extra terms. Just remember your core equations. After that, apply them correctly, and you should get correct. Okay. I hope you understand this video. If not, please replay this video and provide me with some feedback.